Hello and welcome to this Construct 3 tutorial on how to create a bouncing ball game. So you're seeing the end result here now. It's a very simple concept. The ball drops and you can't hit the orange bricks like that, and then the game is over. Up, you see, it's just like basically helix jump, but in 2D. That's it. So the concept is it keeps on dropping, and once you've passed all of the levels, every time you pass a level you get an increase in score. You see that over here, and once you hit the bottom, and there should be a bottom somewhere, there we are, the little purple bricks are the bottom. Once you hit the bottom, congratulations and stuff like that. So this little template here only contains one level with a limited set of bricks, but of course if you want to implement this game you can make as many levels if you like, with as many bricks if you like, with some twists and stuff like that. It's up to you. I will show you the way the game is made and how it can be extended. So let's see, this is the main layout of the game. So this ball here has been placed in the middle of the game, above the layout, and it's been given the platform behavior with default controls disabled. That means it will not listen to the default controls. The jump strength has also been slightly tweaked and made the ball bounce a little harder. Furthermore, it also has the scroll to behavior, so the camera moves along with the ball. To do this, Unbounded Scrolling has been activated on the game layout. So if you go to the game layout, here we see Unbounded Scrolling. And here we see the platform behavior and scroll to. Now you'll notice I've used the platform behavior and not the physics behavior. Now in theory the physics behavior would let the ball drop as well, but the disadvantage there is that the physics behavior would change the behavior of the ball in time. For example, the bouncing would decrease, or whenever you move the platforms, the orientation and the direction of the ball would change as well. So that's not the idea. The ball should stay right in the middle, and it's only the platforms that should go left and right. And that's why I chose the platform behavior, and I'll show you in a minute why that is. So I've created a simple single level to demonstrate how it works. It's up to you to come up with more levels. It's simply a matter of placing bricks, that's it. The ball just keeps on falling, and when it hits a brick, it bounces up. Bricks have been grouped into the brick family, and the brick family has a solid behavior, so the ball will bounce off of it. You can see that here, bricks with the solid behavior. The orange bricks have also been grouped into the bad bricks family, so we can check if a bad brick is in the game over condition or not. That's a bad brick. As you can see, I've provided already some extra sprites for you to use in your game. I've only used 1 or 2 single sprites, but you can put as many sprites in there as you want, and it's just a question of adding them to the bricks and to the bad bricks to let the game take them into account as a solid, or as a solid which triggers a game over state. So the holes family just serves as a grouping of the yellow blocks that are invisible at runtime. When the ball collides with one, the score is increased. So this is the holes. There's a small hole and a large hole. I've only used a small hole here. That's what it's for. And finally, everything that needs to move along with the mouse is in the attachables family. This is because it has a pin behavior. At the runtime, they are pinned to an object called a dragger. Let me show you first the attachables. So everything that needs to move is attachable. It means the ordinary bricks, the bad bricks, and holes are all attachable, and they all attach to a dragger. And the dragger is hidden right now. Let me show you here. This is a simple sprite, but we've added the drag drop behavior. So we can drag and drop this sprite to the left and to the right, and because every attachable is attached to that dragger, it goes along left and right with it. And that's it. And the dialog and the HUD has been set to a scale rate of 0 and a parallax of 0. You will see that here. That's because once the game starts scrolling down, because the ball, excuse me, is falling down, and if we show the dialog, for example, or we let the HUD be visible on top, it would scroll along up to the top, and it would be invisible after a while, because it's scrolling down, the ball is scrolling down all of the time, and the dialog and the HUD would be out of range. If you set scale rate and parallax to 0, it will always remain at the same place on the user screen, independent of where you are in the layout. So that's a little trick. So let me see here what the code is all about. So on start of the game, we just hide the dialog. We've created a function for that. We'll come back to that in a minute. And they enable the drag drop behavior of the dragger, so the user can start moving the blocks. We set the platform behavior of the ball enabled, so it starts falling down and it's able to bounce. And we initialize the score, of course. And then we pick all the attachables and pin the attachables to the dragger. Simple as that. And we pick all the holes and make all the holes transparent as well. Very simple here on collision with the bricks. When a ball hits the brick, it should simulate a jump. That's it. Just once it hits a brick, it just jumps up again, because the code says simulate jump up. That's it. There is a dragger, and the dragger should stay within the limits of the layout. So you could argue and say, okay, you could use the behavior bound to layout. That's something you could do, but in my experience, it is so that if you use the bound to layout behavior, there are some artifacts and there's some weird behavior when you go to the edge of the screen with your mouse. That's why I've implemented it this way. While we are dragging and the x coordinate becomes less than 0, so we're dragging too far to the left, we just set it to 0, we clamp it to 0 actually. And when the x coordinate is larger than the layout width, that means we're dragging too far to the right, and we clamp it to the layout width. That's it. So very simple. On collision with bad bricks, we show the dialog with success with a parameter 0. On collision with the bottom, success meaning 1. Congratulations. And when we collide with a hole, add 1 to the score. And every tick, whenever the score changes, just set the score. That's it. And then there are also some logic for the dialog. On tap of the button of the dialog, we should just restart the layout. That's it. The show dialog function will get a parameter called success, and depending on that success, we will pick the text here in the dialog and set the text in the dialog depending on if it's success or not to congratulations or game over. That's it. So whenever we're showing a dialog, we're setting the dialog layer visible to show it and activate the logic here so we can press the restart button. And we also disable the platform and drag drop behavior, so the ball stops bouncing and we stop dragging the dragger around. That's it. High dialog, excuse me, will show you the dialog, will hide the dialog label, and will also deactivate the dialog logic. So that's it. I hope you enjoyed this tutorial. As always, please like and subscribe, and if you would like to see the full template in action, I will provide a link in the description to the Sera store where you can get it. Thank you for watching.